Hello and welcome to my blog. This is my name and this is me, and in this video I'm going to show you short previews of some of the video that you're going to be able to see here. So we are going to see the previews of these three videos, and we are going to start with the first one, macroeconomic, indifferent curves and budget constraints. Okay, so if you click here, consumer indifferent curve, you have all of these videos, and now I'm going to show you a very brief preview of this video simulation. So we are going to use a Cobb-Douglas function, which is this one, and we will see that we can change this parameter to see how it behaves. And then we will see a budget constraint, which is this one, and we will change prices to see how this line changes. And then we are going to change the budget, so we will see the shifts here, and we can see this line in 3 dimensions. So when we do this shift, you will see a shift here and a shift there, and we are going to find this optimum value in mathematically using substitution and Lagrange that you can see in this video, approaches to indifferent curve and budget constraint. And then we are going to see, if you know already MATLAB, we are going to see how we program this thing, which is this last subject. And here we can change the transparency, so this transparency will allow you to see the indifferent curves in 3 dimensions. So if you go like this, then you can see that this is the same like this. Or the opposite, if we start from the beginning and then you turn this, then you can see that this is the 3-dimension representation. This is exactly like this, but without this surface. Okay, so this graphic way of watching things might help you to understand this concept. Okay, so now let's go to the second video, which is macroeconomic, fiscal and monetary policy in the short run. You access to this video, you can click here and then you go to macroeconomy, short run, and we are going to see monetary policy and policy mix. So what we are going to see in this video is that you can increase, let's say, from 600 to 800, and then you can see the effect in the IS curve, LM curve, etc. Or you can, let's start from the beginning, you can increase government expenditure, and then you see that in this case the interest rate goes up. Or you can use a policy mix. So if you use policy mix, then you can do both, increase money supply and increase government expenditure, and then you can see how the economy goes from this point to this point. Now if you want to know the causality of this shift and in this movement, then what you can do is to go step by step, and then if you increase the money supply, then what you see is the step-by-step causality with the explanation here how these graphs are connected. So you can understand, for example, here why if the interest rates go down, then the exchange rate will go up, for example. Okay, and finally you can see why in this case the economy goes from this point to this point. and then you can change coefficients here, maximum propensity to consume, sensitivity of investment with respect to interest rate, etc., to see how the slope of this line change. Okay, so finally we are going to follow the third step, which is econometric, that you can find here. Econometric, we are going to see this part simulation very briefly. So let's go to the last preview. Okay, let's assume that here we have quantity, and this cyan line represent the revenue, assuming that it's a linear function. And now we want to represent the cost function, and if we take a 10 point and we approximate the cost function with the polynomial degree 3, then let's say that these are the data that we have, that, as you know, is going down, and then there is a point in which the slope starts to go up. So this is the function that best approximate this point. So if you want to find the maximum benefit, you have to find the point, the quantity, in which the difference between revenue and cost are the biggest, so about here. Now if you want to represent a linear function, then you can write here that the polynomial degree is going to be 1, and then let's say that here you have real GDP and here you have inflation. So this is going to represent a Philip curve, not as usual inflation versus unemployment, which is like this, going down, but in this case inflation versus real GDP, that goes up. So if you have the data for many years where the GDP was here, let's say 3, and the inflation was about here, okay, and then another year here, and then another year here, here, like this, and then you can calculate the best. This magenta line is the line that best approximate this point, and in order to understand this concept intuitively, we can see that all of these segments represent the distance from this point to the line. And if you take this segment square, and then you sum it all, and then you divide it by the quantity of points, then you get the error of this approximation. So this magenta line is the line with the minimum error. So in order to find this line, what you need is an intercept here and a slope. So if you want to find the minimum error, what you do is you take the derivative of this error function. You take the derivative of this error function respect to the intercept and respect to the slope, and then you can find the value of the intercept b and the value of the slope m, and in both cases this 1.5 roughly is the error of this approximation. And also you can find a statistical expression to find b and m. So this is basically what you are going to see in these videos. But if you are not familiar with mathematical concept and statistics, you should start first here and then go to simulation. Okay, and finally you can go here using this page, and then it shows you how to use this page depending on whether you are a beginner or you are advanced. Okay, that's it. Thanks for watching and see you in the next video.